All right, this is the practice chapter 1 test, and I am the amazing Mr. Jansen. So if we take a look at the first one, it says, name all the sets of numbers in which negative 2 belongs. We're going to start at the top. Negative 2 is a real number. It's not fake. I can see it. There it is. It's also a rational number because it can be expressed as a fraction, negative 2 over 1. It's an integer because the integers include whole numbers and their opposites. But then because it's negative, it's not a whole number. It's not a natural number. It's just these three. Okay. For number 2, it says name the property illustrated by xy equals yx. We're using multiplication here, and what happens is we took these and switched the order in which we did them. So when we take and switch the order like that, it means we're using our commutative property. So this is commutative. And it's the commutative property of multiplication, but as long as you put commutative there, that's fine. All right. For the next one, it says name the property illustrated by negative 5 plus 0 equals negative 5. And this is our identity property of addition. So as long as you put identity, that's fine. It's identifying the number 5 by adding nothing to it. All right. For the next few, we're just simplifying. So this first one, we have to follow order of operations, which means I'm going to start inside the parentheses. So I'm going to start with this stuff. And inside the parentheses, I want to start with my exponent. So I'm going to have negative 3 times the quantity 16, and that's a division sign, divided by 4 minus 8, plus 6 times, and this should be, looks like I lost part of this. That should be a 1/3 there, times the 1/3. And now inside the parentheses, I'm going to do the division next. So that's negative 3 times the quantity 4 minus 8, plus, over here, I can do this multiplication. This is going to leave me with a 2. Now I do what's left inside the parentheses. So I'm going to have negative 3 times a negative 4 plus 2. So that's 12 plus 2, which equals 14. All right, so we're just using order of operations there. For this next one, we can't solve this because there's no equal sign here. So we're just going to distribute. We're going to simplify it as far as we can. So we're going to distribute and combine like terms. If I distribute the 4, it leaves me with 4x plus 4. Over here, I'm distributing this entire thing. So the negative sign tags along for the ride. So I'm distributing a negative 2. So it gives me a negative 2x plus 10. Negative times a negative is a positive. And now I'm going to combine like terms. So the 4x and the minus 2x, the 4 and the 10. So that's going to leave me with a 2x plus 14. Okay, and that's how I leave my answer. All right, we're just simplifying that one. Taking a look at the next one, this is the one, your paper might be missing the d equals 2. So make sure you have that. We're going to plug each of these in. So that's going to be a, which is 2/3, times c cubed, which is going to be 3 to the 3rd, minus b, which is a negative 2 squared, times d, which is 2, times e, which is a 3/2. And now I'm just going to follow order of operations. So I'm going to do the exponents first. So I have 2/3 times 27 minus a negative 2 squared is going to give us a positive 4. So we have 4 times 2 times 3/2. And I'm going to do the multiplication on each side. Over here, the 2/3 times the 27. Let's see, we can cross-reduce. Let me show you this. We can cross-reduce the 3 and the 27, reduce to a 1 and a 9. So when I multiply those two, it's going to leave me with an 18. Over here, I can do the same thing. I can cross-reduce with these two. So that's going to leave me with a 1 and a 1. So really, I'm just multiplying 3 and 4, which is a 12. And that's going to leave me with 6. All right, for my final answer. Okay? If we're looking at number 7, we're doing the same kind of thing. We're just plugging each of these in. So I've got the absolute value of z, which is negative 2, minus 3 times the absolute value of 5 times x, which is the 3/5, times y, which is the negative 3. And we're taking the absolute value of that. All right, I want to start inside the absolute value symbol. So over here, I'm doing this multiplication. Once again, I can cross-reduce. The 5s can cancel each other out, leaves me with 1 and 1. So when I multiply what's inside of there, I'm going to be left with a negative 9. And now I'm going to take the absolute value right here of absolute value of 2, and then I'm going to take the absolute value of 9. So the absolute value of 2 is 2, so I have 2 minus 3 times the absolute value of negative 9 is going to leave us with a 9. So it's just 3 times 9, which is going to be 27. 2 minus 27 is going to give us a negative 25. All right, we have to simplify everything that's inside the absolute value before we actually take the absolute value. All right. For number 8, we're solving for y. So the first thing we have to do here is we've got to multiply each side by 2. We're getting rid of the fraction. Whatever I do to one side, I have to do to the other side. So over here, I'm going to have 2a equals. Over here, the 2's are going to cancel out. And I'm just going to be left with the x plus y. And now I need to solve for y, so I'm going to subtract the x from each side. So I end up with, let me rewrite it down here. That's going to be 2a minus x equals y. So right here, y equals 2a minus x. Okay? And that's all there is to it. For the next one, we're solving for h. Notice the only place I have an h is right here, which means that this whole first term, since it doesn't have an h in it, that whole first term can go. And since those things are being added, to get rid of it, I have to subtract it. So I'm subtracting the 2 pi r squared from each side. Whatever I do to one side, I have to do to the other side. Okay, so over here, I'm going to be left with a minus 2 pi r squared. And that's not written very well. Let me try again. It's terrible, Mr. Jansen. You should be ashamed of yourself. Maybe a little. There we go. That looks like it's squared. So I'm doing a minus 2 pi r squared. Over here, on this side of the equation, I'm just left with 2 pi rh. And now in order to solve for h, since all of these things, I'm just multiplying by these three things. So to undo multiplication, all I have to do is divide by the 2 pi r. Whatever I do to one side, I have to do to the other side. 2 pi r. So that means over here, this big ugly fraction is going to stay right here where it is. Okay, we can't simplify it at all. And once again, my 2 looks hideous. Oh, my kingdom for a 2. There we go. So that's the big ugly fraction we get. Over here, all this stuff is going to cancel out, so we're just left with the h. All right, so h equals a minus 2 pi r squared all over 2 pi r. And we just have to leave it like that, and that's fine. All right? If we take a look at the next one, it says just to solve each of these. So remember, the rule of thumb here is to simplify and then solve. So I've got 3x minus 6 equals. Over here, I'm going to use my distributive property, so I'm going to distribute the 2. So that's going to leave me with 4 minus 2x. And now I just need to get my x's on one side, my constant terms on the other. So I'm going to add the 2x to each side. So that's going to give me 5x minus 6 equals 4. And now I'm going to add the 6 to each side. So I end up with 5x equals, and for some reason I can't draw an equal sign either. I don't know what my problem is today. Equals 10. So 5x, let me draw a line to separate these so we don't get confused. So we've got 5x equals 10. Again with the equal sign, Mr. Jansen. This is getting a little ridiculous. You got to calm yourself down. So we're going to divide each side by 5 and end up with x equals 2. All right? And we can always plug that back in and check just to make sure it works. All righty? For the next one, the first thing we want to do is we want to get rid of these fractions because we all hate dealing with fractions. So I'm going to multiply each side by the common denominator. And the common denominator here is 12. So I'm going to multiply each side by 12. Over here, I've got to distribute in order to do the multiplication. So when I multiply this, this is going to be 24 over 3x minus 36 over 4 equal to 12 over 12. And you don't have to show that step if you don't want to. This is going to reduce to 8x minus 9 equals 1. So then I have to add the 9 to each side. So I end up with 8x equals 10. I divide each side by 8, and I end up with x equals, now I can leave it as an improper fraction, which is what I'm going to do, but I have to reduce it so it's 5/4. Okay? So 5/4. If you want to write it as a mixed number, you can, or as a decimal, that'd be fine, just fine. All right? For the next one, once again, we have to distribute. So I'm going to distribute the 4, or the -4 rather. So that's going to leave me with -4z plus 8 equal to 24. And now I just need to solve this for z. So I'm going to subtract the 8 from each side. So that's going to leave me with -4z equals 16. And now I divide each side by -4. And that -4 looks hideous, Mr. Jansen. You should be ashamed of yourself. Let me try again. So we've got z equals a -4. All right, and that's it. That's all there's to it. Okay? For the next one, since we have the absolute value here, remember that what's inside the absolute value could be positive or negative before it gets changed. So we have to split this into two equations. We're going to have 2x minus 5 equals what's over here, which is the 5. But we're also going to have what's inside the absolute value, the 2x minus 5, could equal the opposite of what's over there. So we set it also equal to a -5. And now I need to solve each of these equations. So I'm going to add 5 to each side. So I get 2x equals 10. I divide each side by 2, and I find out that x equals 5. Now I got to do the same thing over here. I add 5 to each side. So I get 2x equals 0, divide each side by 2, and find out that x equals 0. So I have two solutions here, x equals 5 and x equals 0. And if I plug each of those back in, I find out that each of them works. Okay, just do a mental check, make sure they work. All right. Next one, same thing. I'm going to split it into two equations. So I've got 3x plus 12 equals 6. I also set it equal to the opposite. So 3x plus 12 equals a -6. And now I need to solve each one, so I'm going to subtract 12 from each side. That looks ugly. Let me try again. Oh, yeah, I've written numbers before. Okay, I remember how this goes. So that's 3x equals a -6. Divide each side by 3. And I find out that x equals -2. All right. Solve the other one, subtract 12 from each side. I get 3x equals a -18. Divide each side by 3. And I find out that x equals a -6. And once again, the last thing I want to do is plug these back in, make sure that they work. And if I do that, I find out that each of these does. All right, always check for extraneous solutions. For the next one, very similar to the problems we just did, except this time we've got stuff in the way. All right, we've got to get the absolute value by itself before we can split it up into two equations. So over here, I got to get the absolute value by itself first. So I'm going to subtract 3 from each side. And that's going to leave me with 4 times the absolute value of 2x minus 1 equals 21. I'm also going to divide by the 4. To undo multiplication, I have to divide by the 4. So that's going to leave me with the absolute value of 2x minus 1 equals 21 over 4. Now the absolute value is by itself. So once we have the absolute value by itself like this, now I'm going to split it up into two equations. So I'm going to use 2x minus 1 equals 21 over 4. And I'm going to do 2x minus 1 equals the opposite of that, so negative 21 over 4. All right, I'm going to solve each of these. First thing I'm going to do here is I'm going to multiply through to get rid of the fraction. So I'm going to multiply each side by 4 to get rid of this fraction. Over here, I've got to distribute, so that's 8x minus 4 equals, over here I'm left with 21. Now I've got to solve this, so I'm going to add 4 to each side. So that's going to leave me with 8x equals 25. Divide each side by 8, and I get x equals, and I'm just going to leave it as an improper fraction, 25 over 8. Okay? The other end of this, I've got to add, well, once again, I want to get rid of the fraction, so I'm going to multiply each side by the common denominator, which is the 4. So that's going to leave me with 8x minus 4 equals a negative 21. I've got to add the 4 to each side. So I have 8x equals a negative 17. Divide each side by 8. And I find out that x equals a negative 17/8. And I can leave it as an improper fraction, right like that. Okay? If you wrote these as mixed numbers, that's fine. If you write them to a decimal, that's okay too. All right? For the next one, same thing. We got to get the absolute value by itself before we split it up. So to get the absolute value by itself, I'm going to divide each side by 5 to undo that multiplication. So that's going to leave me with the absolute value of x plus 2 equals 4x minus 2 over 5. All right, it's okay to have a fraction over there. That's fine. Now that the absolute value is by itself, I'm going to split this up. So I've got x plus 2 equals 4x minus 2 over 5. I'm also going to have x plus 2 equals the opposite of that. So that's going to be a negative 4x plus 2 over 5. Okay, I basically make the numerator negative, but I have to distribute that negative sign. And now I've got to solve this one. Over here, I'm going to get rid of the fraction by multiplying through by the common denominator. So that's going to leave me here. I've got to distribute, so that's 5x plus 10 equals. Over here, the 5's cancel, so I'm left with 4x minus 2. Now I've got to get my variables on one side, constant terms on the other. I'm going to subtract the 4x. So that's going to leave me with x plus 10 equals a negative 2. I've got to subtract the 10 from each side. So I end up with x equals a negative 12. Okay? Same thing over here. I'm going to multiply through by the common denominator to get rid of the fractions first. So I'm going to multiply each side by 5. So over here, I've got to distribute the 5. So that's going to give me 5x plus 10 equals. Over here, the 5's cancel. So I'm left with the negative 4x plus 2. I'm going to add the 4x to each side. So that gives me 9x plus 10 equals 2. I've got to subtract the 10 from each side. So I end up with 9x equals a negative 8. Divide each side by 9. And I get x equals a negative 8/9. Okay? So my two solutions here are negative 12 and a negative 8/9. And once again, you can plug those things back in, check to make sure they work. All right? But you got to isolate the absolute value before we split it up into two equations. So isolate the absolute value, split it into two equations, and solve. For this next one, a lot of people were splitting this one up. There's no absolute value here, so I just have to solve this one. Undo adding a 12 by subtracting 12 from each side. So I get 7x is less than, the sign stays the same unless we multiply or divide by a negative. So that's going to be 63. Divide each side by 7, and we get x is less than 9. And notice the sign stays the same because we didn't multiply or divide by a negative. To set up my number line, I've got 0, 9 would be up here somewhere, and I want to be less than that, so you'd use an open circle because 9 is not included. There's no equal to condition, and draw everything to the left. All right? For the next one, same kind of thing. We got to get all the variables to one side, all the constant terms to the other. So here, I'm going to add 3x to each side. So that's going to give me a negative 3x minus 10 is less than or equal to 14. I'm going to add the 10 to each side. So I've got negative 3x is less than or equal to 24. I got to divide each side by the negative 3. And one of those doesn't look very much like a 3. So rather than use our imaginations, I'll redraw it for you. Oh, that looks beautiful. So now I've got x. Now here I divided by a negative, so I have to flip the inequality sign. So it's greater than or equal to, and this is going to be a negative 8. All right, so once again, I need my 0 on there. I'm going to need a negative 8. It's greater than or equal to. So because of the equal to condition, I use a closed dot, and I want everything that's greater than that. All right? For the next one, compound inequalities. For an and inequality like we see over here, this is an and inequality. That's how we write them. I'm just going to cover part of this up. I don't have anything to cover it with. But if I were to cover a piece of this, let me just blot out this end. The first thing I would do here, if I just had this piece, is I would subtract the 4 from each side, then I'd divide by the 2. So that's what we're going to do. We're going to subtract the 4 from each side. But with a compound inequality, let me bring this fellow back. Whatever we do to one side, we have to do the other side. We also have to do to this third side, so we subtract the 4. Okay? So we subtract the 4 from all three sides, so we get negative 12 is less than or equal to 2x, which is less than a negative 2. Now we divide each side by 2. Whatever I do to one side, I have to do the other side. I also have to do to this third side. So we get negative 6 is less than or equal to x, which is less than a negative 1. So when I plot these, negative 1 is around here somewhere, negative 6 is back here somewhere. Less than, or is the x is between those two things. Since we have the equal to condition over on this side, we put a closed dot, open dot over here because there's no equal to condition, and x falls in between those two values, bigger than negative 6, but less than negative 1. All right? For an or inequality, we just have 2 inequalities we have to solve. So I'm going to solve each of these over here. I've got to add 4 to each side. So I get 11 is greater than z. And if you don't like seeing it that way, rewrite it so the variable comes first, so it's z is less than 11. Or over here, I've got to solve this one, so I'm going to add 14 to each side. So that's going to leave me with 3z is greater than 45. I'm going to divide each side by 3, and I find out that z is greater than 15. All right, so now when I plot this, 0 would be down here somewhere. I suppose 11 would be right around there, which may make 15 right around here. Less than 11, I use an open circle, open dot, and draw everything less than. For the or, since it's or, we're just going to graph both pieces. Greater than this, that's going to be an open circle with everything to the right. All right, and that's it. That's all there is to it. For the next few, for the next two, the last two, I suppose, it's the absolute value. So the absolute value, this is where we have to split it up. We're going to rewrite this as 2 inequalities. Really, we're writing a compound inequality. So we split it up, so we're going to have 4x plus 1 is greater than or equal to 9. We write it down exactly as it is without the absolute value signs. We're also going to have 4x plus 1 is less than or equal to. We flip the inequality sign, and we change the sign of what's over here, the negative 9. And now I have to solve each of these. All right, so I subtract 1 from each side, so I get 4x is greater than or equal to 8. I divide each side by 4, so I get x is greater than or equal to 2. Same thing over here. I'm going to subtract the 1 from each side, so I get 4x is less than or equal to negative 10. I divide each side by 4. So I get x is less than or equal to. And once again, I can write this as a mixed number. I'm going to leave it as an improper fraction. So that's a negative 5/2. All right, which is a negative 2.5. All right. Now to plot this, I'm looking at the sign that's up here. Since the absolute value right here is greater than, that means this is an or inequality. All right. It's an or compound inequality, which means if I've got 0 here, 2 here, and negative 2, so negative 2.5 is going to be back here, and we use a closed dot. Here we use a closed dot. I want everything that's greater than 2, so I draw my arrow up that way, and everything that's less than negative 2.5, so I draw my arrow out that way. And this one's an or, so I leave both of them on there, okay? And then for the last one, same thing, I split it up. I rewrite it exactly as it is. 3 times the quantity x minus 1 is less than or equal to 9. I also rewrite the negative version, which is going to be the 3 times the quantity x minus 1 is greater than or equal to. I flip the inequality sign, change the sign of what's over here, negative 9. Now I solve each. Over here I'm going to distribute, so that's 3x minus 3 is less than or equal to 9. I add 3 to each side, so I get 3x is less than or equal to 12. I divide each side by 3, and I get x is less than or equal to 4. Over here I distribute, that's 3x minus 3 is greater than or equal to negative 9. I add the 3 to each side, so I get 3x is greater than or equal to a negative 6. I divide each side by 3, and I get x is greater than or equal to a negative 2. Now, since this time the absolute value was less than, that means this is going to be an and. I suppose I should change back to a marker. Highlighter doesn't work real well for that. This is going to be an and, which the and I can rewrite as negative 2 less than or equal to x less than or equal to 4, which means if I have my 0 here, negative 2 here, 4 here, I'm going to use a closed dot for each of these because the equal to conditions, and I want everything in between. All right. I hope this was helpful, and good luck on your test.